up. We're starting up our Lightbulb 101, episode 101, Lightbulbs 101. Okay, so what do we have on our display here? Your host here is the Sissy. We're going to, in this particular episode, I'm just going to discuss light bulbs. For those who don't know a lot about wiring or anything about wiring, it's actually house wiring is pretty easy. There's not a lot of different kinds of wires in your house. Really, there's only 3 in your whole house. It's just here and there and everywhere. It's just a lot of them here and there and everywhere, but mainly coming in from the street, you only got 3 wires. You have a hot or a 120. You have a center tap, which is the ground, and you have the other hot. So if you have a high temperature dryer to dry your clothes off, or you have an air conditioner that requires 240 volts, you're going to use both of your hots. And if you just have a regular light bulbs in your rooms, you're only going to be using 120 volts. And that's what we're talking about in this particular video. So on this one over here, this represents your power. 120 volts across these 2 terminals. Don't put your finger there. You're going to have an electric boo-boo. You won't like it. Oh, no. And over here we have a light bulb waiting to be powered up. It wants to show itself off. It says, hey, light me up. Well, let's do just that. Let's take a piece of wire from our power supply here. We're going to stretch a piece to there. Then we're going to drag another piece of wire over to here. And we're going to put it right there. So basically, all this is a wire that goes from this terminal on this power supply, or the negative as they call it, or they also call the negative side ground or neutral in a house. We'll get into that a little bit more. But right now we have a connection from this side of your AC power over to here, over to this side of your light bulb. Now all we need now is one more connection, and the light bulb should turn on. So we're still messing with wires. So let's put a wire to there so it looks nice and neat and straight. And when we let this thing go, we don't have a light bulb yet because we haven't turned on the time. We're still in the building mode. When we hit simulation, now we're going to simulate what's going to happen in real time. So now we hit simulation and the light bulb comes on. They normally don't flicker like that. So now we have power going to both sides of the light and it lights up. Very cool. I turned this one at a parallel to that so you can see the wires coming in on both sides. It makes it easier to see. Okay, so we have one power supply, your power to your house, or your fuse panel, or your breaker panel. You have a wire coming out and going through your walls. The electricians wired your house that way, and they put a light socket in, up in the ceiling, whatever. They wired it up like this. So now you have your negative side coming in and your positive or whatever. Well, this is AC, so really there is no real negative. That's why the current is flowing back and forth. You notice? Notice how it's going left to right to right to left? That's good. Ah, sheesh. It's a Friday where I am, and that was a reminder that it's going to be trash time pretty soon. So I got to get out there soon. But anyway, here we have power going to the light. So that works just fine. If I turn the simulation off, light goes out because time is off. So the next thing would be, and I'm just going to clip out for a second here and then clip right back in. Well, anyway, so what we got here is we're going to go ahead now that we know the light works in the simulation, the light does come on. Let's go ahead now and introduce a switch into the circuit so we can turn our light on and off. Because we don't want to leave it on all the time. So we're going to go ahead to a switch here. Pick up this is called it's called a knife switch. We're going to put that into the circuit, and we're going to break the circuit with that knife switch. And now it interrupts the current from being able to get to the light bulb. So if we go to simulation again, the light bulb does not come on because the switch interrupts the power from being able to get to the light. And a switch is nothing more than basically just two pieces of metal that touch each other. I mean, you could touch the wires together by just making them cross each other and touch. You could do that, but it's more convenient to have a light switch. Hey, touch them two wires together, but don't get in between them. Well, so now we have a switch, so we're going to throw the switch, and hey, look at that, we got power. It's just as if the light had power all the time. Undo, on, undo, on. Just so you know, these switches that they put in light switches, it's a specially treated metal with a coating on it so it can be switched many, many, many times without trying to go bad. Because over time, if you flip a switch 1,000,000 times, every time that metal touches, there's a small spark. And eventually, that spark will get to corrode and disintegrate the metal there, and it'll eat up the metal if you keep flipping it on and off, on and off. So, just for a side note. All right, let's get a little more advanced now. So we have our power and we have our light bulb. Remember, this is the Thomas Edison type of light bulb, you know? Filament inside that gets hot, turns on when voltage is applied to each side of the filament there inside the bulb. And there's only two terminals on a light bulb. Okay, so now what would happen, just for the fun of it, if we were to take another one of these switches and put it in somewhere, say over here, oops, that didn't work. We put another switch in here and put it right about there. All right, so now we're breaking the circuit twice. We're breaking the top circuit and we're breaking the bottom. So if we go to simulation, of course the light bulb is not going to come on because we have to break. We got two breaks in the circuitry. So we have to flip that one on and that one on to get the light to come on. Either one you turn off, yes, the light bulb goes out. It doesn't matter. But they both have to be on before the light will come on. But this is impractical. But there may be instances where this would be needed, but not in today's episode of Lightbulbs 101. 101. So let's go ahead and get rid of this switch. And, well, we can't do it. We've got to go back to here and get rid of this. So we get rid of the switch. We're going to go ahead and hit delete. And we're going to put our wire, back to the way it was. Stretch a piece across here. Snap it in. And we're back to where we were before. Oh, we got to go to simulation. Okay, we have that circuit and it works. Okay, we're happy with that. But now let's just say, let's go back to building. Let's get rid of that, get rid of this, and get rid of this. All right, so we have the same light bulb as we had before and the same power supply, but this time we're going to complicate things just a little bit, but it's actually pretty simple. What we want to do now, we have a room in our house, or it could be a hallway or a room in a building or a garage or some place that has one light bulb to make things easy and simple, just one. But the room is pretty big, let's say, or it's a hallway. And what we want to do is have two switches control the same light, but each switch can turn it on or off depending on which one we throw. So we can't use the same type of switch we did last time. Now we need a different type of switch which has two sides to it and one center. So if we put that right there and we look at this switch, if we get close inspection here, we can see we're going to simulate it working. If we flip it, it goes from one side or the other. It flips either this way or that way. And notice the center is the pivot point. The center is where it swings around back and forth. Okay, so now we're either going to make a connection on this side or on this side, depending on which way we throw the switch. And these are common in households that have 2 light switches controlling 1 bulb or 1 sets of bulbs. So we're going to need 2 of these to make this work. So just for now, I'm going to get out of simulation. We'll go back into build mode, and we're going to get rid of this, and we're going to put our switches over here. We're going to put 1 there. And to make the electrical wiring look more neat, we're going to place these 2 like that, so they're facing each other. And now we're going to run our wires. So now when you get switches on your wall, some electrician had to wire that up. They had to make the interconnections between these 2 light switches wherever they were installed in some house or what application. So they had to do this prior to them putting the walls together with the drywall or whatever. So they had to run these wires ahead of time. So we're going to run our wires the way it was done. So we need a common there, a wire there, and we need a wire there. That's the way it has to be, because either switch at either time can turn on the light. So now what we have just done was we had made these 2 switches, the main output is going to look like one output. It's going to look like one output. So we need to go our wires, and we need to tap a wire here, and we need to tap a wire off of the center tap and bring it over to here. I'm going to keep these wires far apart so it keeps things simple. I'm going to just get rid of that one for now and get a longer wire to make it look better. All right, so now what do we have? Well, both of these light switches are going to appear like one switch to the system, but yet there's actually 2 of them. So now these 2 terminals are what we need to apply to here so that this extra stuff can start working here. So let's get our wiring together some more. So we're going to grab a wire and we're going to go this way, then this way, and you'll see this happen now. There you go. So the bottom of our light goes directly to the power supply. It always does. Sometimes they call it the ground or the neutral in a house, which is usually the white wire. The hot side, or this side, usually is black. So now what do we have? We have a circuit. We're going to simulate this. So at this point right now, the light is not on and we're in the simulation mode, so we're live. So let's look at the current. We know this side's already hooked up to the light, so that half is already done. But this part, let's look at this. We're coming along, we're getting to this switch. Yes, we are. It's going through this switch and going up, but it dead ends. It dead ends right there. It can't go any further. It's trying to get here, but it can't get there. So what would happen if we were to throw this switch? Hey, the light comes on, and let's see why. Why? Knowing what happens is one thing, but knowing why is another thing. So we look at the voltage, the current coming out. We go this way. We come up into the first switch. It's going through the connector to this side. Then it comes up. Then it goes through this connection. And since it's on the center of it, it gets it gets down to the light bulb. So now that works. So we know by flipping this switch here on and off, the light bulb does indeed turn on and off with this switch by itself. All right, so let's test the other switch now. Let's flip this one. Well, it definitely turned it on, and it turned it off. Turns it on, turns it off. So let's turn it back on again. Now we're going to go down to this switch and flip it. So it works. Now in reality, these two switches are not going to be, most probably, not very close together. So these wires would be longer. So let's draw that. We like things as simple as possible, and we want to be able to see everything as it would work in real life to grasp what is happening here. So now we're going to be more like real life. All right, so we got one switch on this side of the room. Let's rotate that. Put it there. Then we got another switch way over here on the other side of the room. Like way over here somewhere. Then we're going to run our wires now. So the tops. So basically, on the switches, you wire the two outer terminals together. It doesn't matter which way the switches are thrown. It doesn't matter. It doesn't matter. Just don't wire the commons to any of that. And then you come out of your common with a wire, which we're on wires. We come out. We come down. I sure didn't want to let go over there. So now our power's coming over this way, it's coming this way, it's coming this way. Well, the last wire is going to go here. All we're doing is redrawing this with more of a distance between us. That's all we've done. It's the same thing, it's just drawn differently with these switches being further apart, so it makes it more like real life. So let's do our simulation. Simulation. Flip it. Light comes on. Flip it. Light goes off. Flip, 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 flip. Good. Flip, 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 flip. It works. Flip. Doesn't matter which way you have it. So you can study the circuitry. So it always goes through one knife of the other one and one knife switch of the other one. So one switch and one switch to get where it needs to go. So both switches are involved. It either comes along the top one or the bottom one, depending on how these are thrown. Pretty simple. It's just a bunch of switches. It's just a bunch of metal touching. Like, does this metal touch or does this metal touch? And that's it. So this is still, we are within episode 101, light bulbs, 101. So I will get a nice swig of cool, crisp water. Okay, so we're going to end the video now. Well, soon, because I want to go a little further. And then we're going to end with some fireworks at the end. So stay tuned for the fireworks if you want to see that happen. The other way to simplify a drawing, depending on how these are drawn up on a schematic for an electrician to follow, or a more simple way to draw something, is to not show the grounded side being wired. We're going to take this out. We're going to put something in called a ground. Now, when they have a ground at when they call it ground at your house, I'm just going to say it's your house. Could be a building, and it could be anything. What they do is at your breaker panel where your power comes in from the power company, at that point there is a terminal strip inside your breaker panel that goes to earth ground. And literally, when I say earth ground, I mean really earth ground. They take a thick wire and they run it through your wall to outside, and they stick an 8-foot copper rod into the ground. They knock it in with a hammer. They stick it all the way down into the earth. I know it sounds kind of stupid, but that's what they do. And they ram it down in there until it's just barely sticking up above the ground. And then they clamp the wire going outside to that. So the wire going out from your breaker or fuse panel goes outside into the grounding rod. And there's quite a bit of talk about grounding, how to ground things and stuff. But literally, your fuse panel has 3 wires. It has an earth ground terminal strip, which has an extra ground wire going to every appliance in your house. And that's more just basically for safety. Then you have, which we're not seeing in this diagram. So now let's redo our drawing a little bit by getting rid of our ground wire. I'm going to get rid of it. And what we're going to do instead is we're going to put what they call a ground thingy there. These represent ground. So if you see this ground representation, that means it's going to ground. If you see this white triangle shape, anywhere you see it on the drawing, anywhere, they're all going to this point. It's the same thing. This ground is the same exact point as this ground without having the wire going in between it. So what it does is it simplifies the drawing depending on how big it can be. This particular little drawing doesn't benefit much from that. But if you got a big hairy drawing of a big building with a lot of wires in it, you don't want to be showing all those ground runs because it would make it way more complicated and more difficult to figure out what is what. But with these grounds, it eliminates a lot of that. So, and let's even simplify it even more by getting rid of this wire completely and putting our ground directly to the terminals where they need to go to really simplify it. Okay, so now let's have a little fun at the end of the video. And we're going to shoot off some rockets and stuff here, so I'm going to back out a little bit. It just so happens, let's do a little bit of playtime. So what we have is, we have some fireworks. We have a spider. Let's put that in. And we have, what is this? A peony, a crosset, chrysanthemum. I don't know. Let's just put this in. We're not going to get into the wiring on this. Or we're not going to get into what these designations are. But let's just try this for fun. Let's just take a ground. Because we know what grounds are now. We've learned what a ground does. So we're going to put it in the middle of both of those things. Now all we need now is a switch. We'll put this, because we know how a switch works now. We know how to do that. We've learned what a switch does. So now we're going to take a wire from our switch. I didn't really want to do what I did. I wanted this. This is messing up. Oh, no, it's not. I was messing up. Let's put our switch in over here instead. And we're going to put a wire between here and here, and here, and there. So what we're doing is, in addition to running our power into the light circuit, we're also running it through a switch into these fireworks thingies. They just happen to work with any voltage. And so we're not going to worry about voltage with these things. So let's go ahead and turn them on and watch these things do their thing. So we're going to go to the simulation now. And we're going to shoot off some stuff here. Now to add on to it, add a little bit of color, we're going to go to this guy. We're going to put this, oops, I always go the wrong way. We're going to put this guy in. All right, and then we're going to put our ground. We know what grounds are. We've learned that pretty doggone good. Basically, it's like one half of the connection. Then we're going to run this up to there, and then to there. So we just got, now we got that also in the circuit. So let's just look at this now, back out, and flip our switch. Oh, we got to be in simulation mode. Let's have some fun. All right, well, I think that was pretty cool. Let's get out of the simulation mode. And let's put this back kind of like where it was. And we're going to just get rid of a couple of these devices. Get rid of this stuff. And then we're just going to look at one quick thing. And that'll be the end of the video. And we're going to look at this. This is in a three-dimensional view because it has height and depth to it. So let's look at the same scenario, but in a two-dimensional drawing, how it would look to an electrician. So we go to 2D. So there's how the actual print would actually look to an electrician. You have your power source, you have your ground, and you have your switches. And if you turn on the power to this to simulate it, and you flip a switch, that's what it looks like. All right, so we're going to go ahead and get out of this and end this video of Lightbulbs 101. And I'll make a number 2 and bring that into the world. All right, that should do it. See ya.